Hi guys. So in this video, I will be discussing about solid design principles. So this is very much important from interview perspective because most of the interviewer will ask you, especially the Liskov substitution principle, which is very much important. Okay. So they will tell you to explain these topics and they can tell you to write a logic for that. Okay. And explain it code wise with real time scenarios. Like how can you explain these solid design principles in your real world scenarios? So that also interviewer can ask you to explain. So let's dive deep into it and understand each and every word, character meaning of it in the solid. So what does that mean actually, and how can we implement it in the real time scenarios? Okay, so let's jump onto it and dive into it and let's see what does it actually mean. Which is very important. These are the main five things which are the acronyms for solids. So S means single responsibility principle, O means open close principle, L is Liskov substitution principle, I is interface segregation, and D is dependency inversion. So why this solid principle came into picture? So because whenever you are writing code, it should be properly understandable and it should be flexible and it should be maintainable, because if you are not writing code in such a maintainable manner, then nobody will able to understand what you have written, right? There should be a proper structure, there should be a proper format that should follow. Otherwise anybody can come and then they can insert the new logic into the existing code and it can disturb the current flow, and maybe it can cause issue, it can create error or exception in the near future. So to avoid that, there are certain set of principle that has came into picture, so which actually maintains the code structure and it increases the efficiency of the code, and it makes the code more readable and understandable as well. Okay, so for that sake, actually five design principles came into picture. So let's jump onto it one by one. The first is single responsibility principle. So what does that mean? What is single responsibility principle? So it simply means a class should have only one responsibility. So what's the meaning of that? So basically it means that there should be only one reason for a particular class to change. Okay, so one class should contain only one set of feature, one set of functionality. One class should not contain different set of functionalities. So let's suppose you are going to a bank. Okay, so bank has a certain set of features, like, so there is a loan features are there, there is opening of account is there, then there is withdrawal feature is there. So will you write all the features in one particular class? No, right? One class would contain only loan related thing, like different types of loan can be there. Okay, personal loan, car loan, four-wheeler loan, two-wheeler loan. There can be various types of loan, and that should come into one particular class, which is of loan type. Second will be of opening account type. So account can be opened in multiple ways, like saving account opening, then trading account opening, then current account opening. So there should be a separate class for that. So each set of class will define its own set of responsibilities, and multiple class should not interfere with each other and makes it more difficult to understand for other person. Okay, so each class should maintain only one single responsibility. That is the reason which is called a single responsibility principle. So now let's understand through code how this actually works. So if you go and try to understand this, so this is basically a bad design principle according to single responsibility principle. Why is it so? If you see it closely here, class employee is there, which is having two field members, name as well as salary. Constructor is being created. But if you closely observe here, there are two methods, calculate salary method and a save employee method. Okay, both are having different set of functionalities. If you observe closely here, calculate salary, it does the salary calculation, how much salary we will get at the end of the month. But saving employee is a totally different set of feature. It's like new employee gets onboarded and that employee needs to get saved into DB. That ID details, that employee details, each and every details of that employee needs to get saved in DB. So that is entirely a different set of functionality which doesn't correlate with the existing method functionality, which is calculate salary. So that's why it violates single responsibility principle. So how can I make good design which gets accustomed with single responsibility principle? So for that, we need to create a separate repository, and there actually we can write this method save employee, so that all DB related operations can be done in that particular interface. So this is actually a good design principle. So according to this, only one method will be present, like calculate salary. So employee class can do only employee related stuffs. like calculating salary. Okay, so if another type of things which employee generally does, so those type of functionality needs to be put in employee. And you can see in employee repository there's a separate class or interface you can create, and there you can add this method save employee, because save, update, delete operation, these are with respect to DB operations. So that those operations which directly interacts with DB and does DML operations, those should be there in the repository layer or the DAO layer, which is data access object layer. So now this is the good design principle as per single responsibility principle. Okay, because each class holds a separate set of responsibilities. So now next comes O. O is open close principle. What is open close principle? So if you see that there are certain set of classes, modules, or entities are there which is open for extension, okay, which are, and that they are closed for modification. What does that mean? So if there is a particular set of class which holds certain set of responsibilities, but you cannot modify the existing class in due to any reason. Okay, so you have written certain set of functionalities within that class. Okay, it is working perfectly fine, it is production ready, it's deployed in production, everything is done. Yeah, then after that, after some time, new feature came, or you can say like new enhancement kind of thing came. So will you disturb the existing functionality in the existing class? No, right? It may create issue in the production level. Okay, so because due to the existing, you are creating new method into the existing layer, in the existing class, then there is a possibility like any issue can come into that particular class. So it will disturb the entire ecosystem of the code written. So for that, actually what we can do, we can create a separate package or a separate class. And then you can inherit the properties of the current class, and then you can modify that method. That way you can do, which will follow open close principle. You are not modifying the existing class, rather you are extending the properties into a new class, and there you are modifying your code as per the new enhancements. So that is basically open close principle. So here you can see this is basically a bad design principle. Okay, why it is a bad design principles? So here you can see shape object shape is an interface. Basically for that a reference has been created, and then we are trying to modify the existing code, and we are trying to add a new functionality for different type of shapes. So one shape is circle, one shape is rectangle. So let's suppose in later point of time triangle comes, then you have to modify this code only. At later point of time, let's suppose parallelogram area we need to calculate, then we have to again modify the existing code. So again and again, if there are new set of diagrams are coming, new set of geometric diagrams are coming, for that we need to calculate perimeter area. So we always and always, you can see you are trying to modify the existing code. So basically it's a bad design principle as per open close principle. So we need to make a good design for that. How can we do that? Just think about it once. How can we do that? If you are thinking something about interface or abstract class, then you are going into a right direction. Okay, so now let's understand the good design principle. So this is basically a good design principle, and we have to implement polymorphism for that. Okay, so if you are knowing about a little bit about polymorphism, so if you can understand it, like if one entity is having different features which behaves differently at different places, those concept is called as polymorphism. So I hope this is a basic OOPS concept which you might be knowing. It is of two types, basically compile time and runtime polymorphism. You can go into that in detail. So if you want to create video separately on that, you can comment it down in the comment box below. I will create a separate video on that as well. So for that, basically to make it more good design open close principle, we can make first abstract class. Okay, then we will be having a calculate area method, because this method is common across all the shapes. If you take like rectangle, if you take square, if you take parallelogram, if you take triangle, all will have the same functionalities to calculate the area. Okay, if there is a new feature is coming like calculate perimeter, that will also be common across all the shapes. That also can be added over here. So as of now, you can take as calculate area. Then comes circle. So circle is one of the shape I'm considering, and then I am extending the feature of the shape. Okay, so here you can consider like a runtime polymorphism is been happening. Okay, so basically inheritance will be there, then method overriding will be there, then upcasting downcasting features will be there. So wherever you will see these three type of things are happening, then you can understand like yes, polymorphism is happening, specifically runtime polymorphism. Okay, so here you can see circle class has been created. Okay, it's basically a shape. and it extends the shape class, which is the abstract class. Okay, it will have certain set of own feature like get radius. Radius is a separate specific feature which is pertaining to circle only. Okay, we are creating constructor for circle, we are having radius. Okay, then we are overriding that method which is present in abstract class, which is calculate area, and then we are writing the formula for calculating the area for that circle, which is pi r square. Okay, then you can see the rectangle class. Rectangle extends shape, but the rectangle is having different set of features. It is having length, breadth. Okay, or you can consider like width, height. Okay, anything we can consider. There is a separate constructor written. You can override the existing calculate area method of the abstract class shape. Okay, and then you can calculate the area, which is length into breadth. And then you can see within the calculate area part, if you consider here, you are calculating area over here. How it is calculating the area over here? Here we are making use of calculate area method. We are passing the shape reference, and then we are calling the calculate area method with this shape reference basically. So here actually what is happening from the main method. So you can try it out in your own IDE. So you can create a separate main method after creating these classes. Then from there actually you can create an object of this area calculator, and then you can pass that specific shape, which shape you want. Let's suppose you want circle. So you can pass radius within the constructor of the circle while creating new object, and then you can call this calculate area method and pass that circle reference over here. Okay, and then you can call the calculate area method. When you will call the calculate area method, then with that radius basically it will calculate the area of that particular circle. So basically it will calculate pi to radius into radius. So like that it will happen. So here you will see anytime if there is any new geometric thing is coming for which you have to calculate area or perimeter, you will not modify the existing code. Rather, you will create a separate class for that, which will extend this abstract class which is shape. Okay, you will not modify the existing code which is already written, and that it follows open close principle. Okay, very properly. So it's not violating this open close principle now, because you are not modifying the existing class circle. So if any new feature is coming, you will create a separate class for that. Let's suppose triangle is coming, parallelogram is coming. Each and every time you will create a separate class. You will extend the shape class. Then you will override this calculate area method, and then you can write your own logic within that for calculating area as well as perimeter. So I hope you got a concept of open close principle. So now let's jump on to the next concept, which is Liskov substitution principle. That is also very much important. So let's try to understand this Liskov substitution principle. I hope you have some idea about Liskov substitution principle. So basically, Liskov substitution principle states that there was a person called as Liskov, okay, who actually invented this term substitution principle. So basically, substitution means you are trying to substitute something with another thing so that the flow of program doesn't get halt, okay, doesn't gets paused. So whatever was the flow of execution, it will maintain that flow, but you can basically exchange the subclass with the superclass properties. Okay, so let's suppose there is a superclass which is the parent class, and then there is a child class which extends the property of that superclass. Then your program should run properly if we are replacing the subclass property with the superclass property. Okay, so it should not break the current state of execution flow if we are replacing the subclass property with superclass property. That is basically the Liskov substitution principle. So here it's written specifically, objects of a superclass should be replaceable with the object of a subclass. Okay, so whatever the objects you have created for superclass, that should be replaceable with the object of the subclass, and then it should be working perfectly fine. And the proper program flow of state will be maintained as well. That should also not get disturbed. So let's jump onto it to the code part, and let's see how does it work. So this you can see it's basically a bad design principle according to Liskov. How? So here you can see there is a class bird which is created, and there is an inbuilt method called fly, where there is a logic of flying for that particular bird is written. But when I'm creating a class called ostrich, which extends this bird class, okay, and then we are overriding this fly method, and then Here you can observe closely, we are throwing unsupported operation exception, which is ostrich can't fly. So here you can observe, can we replace the object of superclass with the object of subclass? Will it work perfectly fine? So according to the superclass, every bird will fly. If you observe class bird, there is a fly method and there is a flying logic written. That means according to this, according to superclass functionality, each and every bird should fly. But if I replace superclass object with a subclass object, which is ostrich, here you can observe that we are overriding the fly method, but we are throwing exception. But the superclass implementation doesn't throw any kind of exception. For the superclass bird, every bird will be able to fly. But if we are making use of ostrich and we are replacing superclass object bird with the subclass object ostrich, then if we are calling fly method, it will throw exception like ostrich can't fly. So from this, you will be able to understand that it violates Liskov substitution principle. So here at this point of time, you can't substitute your superclass bird with your subclass ostrich. So what's the best design according to this Liskov substitution principle? What changes you have to do here? So that we will be seeing now. So here you can observe, according to LSP, first we have to create one abstract class, okay, so that there should not be a disturbance in the existing class flow. You should not disturb the existing class flow. So rather you can create a separate abstract class called flying bird. So here you can create separate classes like those birds which can fly. There can be certain birds which can't fly. So here you can create two separate classes for that. Okay, one separate class for flying birds, one separate class for non-flying birds. That way also you can do, and you can extend separate classes like kiwi or ostrich. You can make them extend non-flying birds. That way also you can do. Okay, so here is one of the example. First, I've created abstract class bird, which constitutes flying as well as non-flying birds. Then we are creating abstract class flying bird, which extends the property of birds, which is right as well. Correct? Because bird property will be extended in flying bird. Whether it's flying or non-flying, bird property will be extended. Then I'm having the fly method. Okay, because flying birds can only fly, right? Non-flying birds can't fly. So only flying bird class should have fly method. Okay, and then sparrow, it's a flying bird. So we can extend flying bird class over here and we can override fly method and we can write our own logic for sparrow. Then when ostrich comes, ostrich will extend a bird class. Okay, so and then within the bird class, whatever logic is implemented, you can override here and you can make the changes. Or what you can do, you can create a separate abstract class called non-flying bird. Then you can extend the bird class over there, and then you can override that. You can create one abstract method which is not fly. Okay, and then you can extend that not flying bird within the class ostrich, like class ostrich extends non-flying bird, and then you can override that non-fly method, and then you can write your own logic for ostrich. That way also can be written. So now you have understood a concept like how Liskov substitution principle works internally, how it should be maintained. Code should be maintained in such a way that it doesn't violate LSP principle. So now let's see certain real-time scenario, real-time use case, so that you will have better in-depth knowledge on this, because LSP is being asked in the interview to write the code for that, explain with real-time scenarios how LSP works. So you should have the clear understanding of this. The rest of them are very easy, but this one actually requires time to understand. So once you understand the thing, it will be very much simple for you. Okay. So one more thing. Yeah, so this is one of the real-time example that you can understand for Liskov substitution principle. Okay, so here I've taken one interface called cleaning, which has certain methods like clean table, clean floor. Okay, then there is a cooking interface created, which has cook dish method. Then there is serving interface created, which is having serve food method. Okay, then there is one abstract class created, which is restaurant staff, where all these internal classes will extend. So it will have get name, the name of that restaurant staff, then perform duties. Some staffs will perform their own duties. So that I've created a method for that. Okay, and whichever type of person is there who is working as a staff, they can be chef, he can be waiter, he can be a cleaner. So there can be three different kind of person. There can be more as well. As of now, we are considering three type of person: cleaner, chef, and waiter. Both will override the methods within that, which is perform duties. So both these three people will perform three different type of duties. Okay, the chef will perform duties like preparing food. Waiter will perform duties like serving customers. Cleaner will perform duties like cleaning the place or the utensils. So there can be three type of people performing three different type of duties. So you can create three separate classes like cleaner, which perform duties, which implements cleaning interface and will override these two methods, clean table and clean floor method. Then comes class chef, which extends this restaurant staff, which is abstract class, and then it will implement cooking interface. So why we are doing like this? Because restaurant staff will have the name and the duties will be performed. But chef will cook the dish, right? Chef will prepare food. For that, we need to have cooking interface as well, which will have cooking features, which will override within the chef class. So here we are overriding cook dish method as well, and we can override and make some changes onto it. Okay. Then comes waiter. Waiter will have their own name. Waiter will perform certain type of duties by overriding this restaurant class, as well as it will implement serving interface as well, because waiter will serve food to the customers, right? So there will be serve food method within serving interface, and then we will override that within waiter class, and then we will write our own logic like how that particular waiter will serve the food. So that logic will be implemented in the waiter class. So I hope you got the concept here. So there is one abstract class called restaurant staff. All these staffs, cleaner, chef, waiter, will extend the properties of this restaurant class by getting the name and what duties they will perform, that they will override and make the changes. Then cleaner will do the cleaning process, so it will implement cleaning interface. Then chef will implement cooking interface, and waiter will implement serving interface. Okay, so now how it will be working in the code, now that will be discussing it now. So let's see the code for this once. So here, if you see the code part once, so what we are doing, so as per the diagram, if you clearly remember, so one was restaurant staff. So we have created restaurant staff, which contains name, okay, get name, and then we are having abstract method called perform duties. And then how many type of staffs will be present in the restaurant? There can be multiple, but we can consider as of now like cleaner who cleans utensils. Then there will be chef who will prepare the dish, and there will be serving who will serve the food to the customers. So for that, we have created multiple classes. So here you can see I've created one class chef, which will extend restaurant staff, which will implement cooking interface. Okay, will create constructor here, and then we will override cook dish method. Cook dish method is present where? It is present within cooking interface. And then we are overriding perform duties method of restaurant staff class. Okay, so here if you go in the cooking interface, you will see cook dish method is written. Okay, which is abstract public void type. So like this, it is implemented. Okay, so I hope you got a clarity like how it is being implemented. Then cleaning is there, which will have clean table and clean floors. Okay, then there is serving class, which will have serve food method. Then there is a waiter class, which will extend restaurant staff class and will implement serving. So like that, these all things are being implemented over here. Okay, so now we will see the thing called restaurant staff. So restaurant staff is an abstract class. I already told you it will have name and a perform duties functionalities. Then there is a main method present, which is restaurant staff, restaurant class. Okay, and we are creating the object for restaurant staff. So restaurant staff can be chef, can be waiter, can be cleaner as well. Okay, so here we are doing the upcasting, basically polymorphism we are doing. So here we are assigning with a constructor and name, we are assigning name for the chef, which is John. So we are creating object through constructor. We are passing name here, and then we are upcasting it to restaurant staff type, because all these class chef, waiter, cleaner extends the super class, which is restaurant staff. We are creating name waiter, Emma. We are creating name for cleaner, which is Mike. Okay, and all are extending restaurant staff class. And then what we are doing, we are calling this perform staff duties method. And within perform staff duties, we are passing this reference, like who is that particular person who is performing the duty, chef, waiter, or cleaner. So we are passing them one by one, and then we are making them perform their duties. So now if I run the code, here you will see the output. John was a chef. So now John is cooking a dish. Okay. Then comes Emma. Emma is a waiter. So waiter will serve the food. So am I serving food? Then Mike is a cleaner. So Mike will clean the table and Mike will clean the floor. Okay. So now the superclass object can be replaced with a subclass object and it will work perfectly fine. Here you can see the result. Okay. So all the here superclass object can be replaced with subclass and then also you will get the same output. So it follows Liskov substitution principle. So now here comes the trick. Now how can you violate this LSP principle? What will you do now so that LSP principle gets violated? So for that, we have created part-time cleaner. Okay. So here you can see I've created one class called part-time cleaner. So here it extends the cleaner interface. Okay. So here you can see I've created one separate class cleaner, which extends restaurant staff, which implements cleaning. So here we have overridden clean table, clean floor, and perform duties. Perform duties of what? Cleaning table and cleaning floor. These are the duties performed by the cleaner person. Okay. Who will clean the data, clean the food items basically. Then comes we are extending cleaner. So all those features will automatically be coming in part-time cleaner. We are creating constructor. We are overriding clean floor. But here, if you observe, we are throwing new unsupported operation exception like part-time cleaner cannot clean floors. So there can be a scenario like there part-time cleaners are there, okay, who is cleaning, but there can be a chance that particular cleaner is not biased particularly towards cleaning floors. They are focused towards cleaning tables or dishes, but he or she is not supposed to clean floor. For them, actually, there are different kind of person are there. That person is not appointed to clean floor. So if that is the scenario, will it not violate LSP principle? Just think about it once. Can we replace superclass object with the subclass object if this type of functionality is there, where clean floor is not allowed by the cleaner? You will not be able to replace superclass with subclass object, right? It will throw exception like part-time cleaner is there. I will not be able to clean floor. I will not be able to do that. But that particular feature was not implemented in the superclass. So it violates the Liskov substitution principle. Okay. So let's show you once how it violates that. So let me go to restaurant class. So let me now uncomment this part. Okay, and let's run this code. I've thrown exception for cleaning floor. So now if I run the code, here you will see it's showing exception. Till Alex is working fine. Okay, Alex is cleaning the table. But as soon as this Alex person was told, please clean the floor. Alex person was told now to clean the floor. Till the table he cleaned. Till the table part he has cleaned. But when he was told to clean the floor, it started throwing me exception. Like part-time cleaner cannot clean floors. Okay. So it specifically violates Liskov substitution principle. Okay. Here you cannot replace superclass object with a subclass object. So this is the way you can implement it in the real-time scenario. And how you can resolve this issue? For part-time cleaner, you should create a separate class, okay, which will extend this abstract class property, and then you can write this logic for that. And then you can create a separate object for that particular class, and there actually you can call that method and write the logic specifically for that. That way you can do. So try to do it by yourself. Try to resolve this issue by making it LSP compliant. Okay. So that was a thing which I wanted to tell you, because LSP is very much important. It is asked multiple times in the interview. So this concept should be very much clear in your mind. So now let's go jump onto the next set of design principle, which is interface segregation principle. Okay. So next comes interface segregation principle. So interface segregation principle states that the clients should not be forced to depend upon interfaces, okay, which they shouldn't use. So let's suppose a client wants to use certain features of a restaurant, like eating a specific type of food, like North Indian food, and that particular client wants to pay the bill. Will that client will watch this? No, right? Will that client will see like how many types of menu are there and how they are preparing those menus? No, right? Clients are not interested in that. Clients are like users, those who are going to have food in the restaurant. They are more focused towards having food. They will at max see like what all dishes are there in the menu. They will see those dishes and they will select few dishes out of that, and then after having that dish, after taking the food, they will pay the bill. Okay, so these two features only the particular customer will do. They will first of all select the dish, they will have the dish, okay, and then they will pay the bill. They will not wash the utensils over there until unless they are paying the bill properly, okay, and then they will not see like how they are preparing food. Okay, they will not check the database like previously what all type of food were there, currently what all type of food is there, and what new type of food will be coming in the future. Okay, so those type of things will not see at that point of time when that customer is hungry and he or she has came here to have the food. Okay, so clients should see only those things which that particular client needs, not any other type of things. Okay, so for that sake, interface segregation came into picture, where we are segregating a big interface containing multiple set of methods with towards multiple interfaces, so that if there are three clients will be dedicated towards those three interfaces, and each interface will contain only one or two or few methods which that particular client needs, so that there should not be multiple unused methods which the client doesn't need. So clients should get only those methods which is important for that client, not other methods which the client doesn't need. So we will segregate interface according to the needs of the client. So let's understand more on it. So first of all, we will see the bad design. So here you will see there is a single large interface worker. Okay, so worker is there, and there is a method called work method is there, then eat method is there. So which client will focus upon working and which clients will focus upon eating? Maybe all the clients will not focus upon work and eat both. Okay, how? Let me tell you with example. So here if you observe what I've written, so this is basically a good design principle. Why? Because we have created first interface workable, then interface eatable. Workable interface will have work method, eatable interface will have eat method. There's separate functionalities available. Then we are creating worker class IMPL, which implements workable and eatable, because those who are worker, those who are employees, they will have food and they will work as well. If you are going to a work in IT sector, will you not have lunch over there? Will you not have evening snacks or dinner over there? You will have food over there as well, right? Along with working, you can't work day in and day out in the company. You will work as well, and then you will have food as well over there. So is if he or she is a worker and he is coming into office, then they will work as well and they will eat as well. So we are clients who will work as well as eat. But let's suppose there is a robot there. Okay, so robot will not eat, right? Robot will only work. So at that point of time, for robot client, we should not show them eatable interface. Okay, so there should be a class robot which will have only work method present. It should not have eat method. So robot will implement only workable interface and it will override only work method. Robot is not focusing upon what type of menu items are there in the food section. Okay, so like this, if you segregate across multiple interfaces, then the clients will utilize only those methods which that particular client needs. I hope you got the clarity on this. So now let's jump on to the last design principle, which is the D, which is dependency inversion. Okay, so let's jump onto it. Okay, so from the name itself, we will get to know like what is this? We are inverting the dependency. So the best example is Spring Boot dependency principle. Okay, so there the inversion of dependency is there, where we are not creating object, rather we are instructing Spring container to create the object for us and inject them as and when required. That is basically a dependency inversion principle. We are not creating object for that. We are telling Spring container, please help me create the object and inject it whenever it's required. I don't want to create the object. So we are giving the responsibility back to the container. So that is actually the best example for dependency inversion principle. So here there are two concepts basically. Higher level modules should not depend upon lower level modules. Rather, both should depend upon abstraction. So there should be abstraction layer where it contains the features, and then we are overriding that methods in a class, and then we are implementing our logic. Okay, so higher level modules should not depend upon lower level modules directly. Otherwise, there will be a tight coupling. So there should be a loose coupling. Okay, and second point is abstraction should not depend upon details. Okay, rather details should depend upon abstraction. So whatever things you are writing by extending that abstract class or interface, you are overriding the method. So those are the basically details part, and details should depend upon the abstraction. And abstraction should be independent of the details. That is basically the meaning of this. So these two concepts should be very much clear in your mind. Okay. So this is one of the example where it shows the bad design. Okay. So here what we are doing, here we are creating one light bulb. Okay. Then there is turn on and turn off feature is there in that light bulb. Okay. So whenever turn on method is called, light bulb will be turned on. When there is turn off method, light bulb will be turned off. So we are creating one class called switch. We are creating the reference object for light bulb. Okay. So here you can see the main class is the switch class where the high level module is there. So here you can see high level module, which is the switch class, is directly dependent on low level module, which is the light bulb. Okay. So there is a strong dependency between the two. And we are creating operate method. We are passing the command over here like on and off. So based upon that, it will call the particular light bulb reference, and then it will call turn on or turn off method based upon the command which we are passing in the operate method. So here you can see switch class is directly dependent upon light bulb. Okay. And we are giving the command. It will call the operate method. It will call turn on or turn off based upon the command we are passing in the operate method. So here you can see there's a strong dependency between light bulb and switch class. So how can we make it a good design as per dependency inversion principle? So we should segregate it. Okay. So here if you observe, so this is basically a good design principle where high level module is depending upon abstraction. Okay. So we are creating one interface called switchable. Okay. We are having turn on, turn off method rather than creating a separate class and implementing it. We can first create an interface for switchable class, for switchable interface. Then we are having turn on and turn off methods within that. Then whichever class want to make use of it, they can directly implement this interface. So first is light bulb class, which implements switchable interface. Then there will be turn on, turn off feature will be there. Then there will be a switch class, which will have operate method. And then we are passing the command over here. So if it is on, the device will get turned on. If it is off, it will be turned off. It will call the turn on, turn off method from the light bulb. Okay. So I hope you are getting the idea on this. So there is a class switch. Within that, we are creating switchable device reference, switchable interface reference we are creating. Then from the command, we are passing the command, like what we want to do. So here you can see device is the reference of switchable. We are calling turn on method. So whenever turn on method is called, here it will come to turn on method and it will turn on the light. Okay. So like this, it will get connected. So there is a loose coupling between the two. So now light bulb and switch is not tightly coupled. They are loosely coupled. So now dependency got inverted. Okay. So both are depending upon abstraction. Okay. Abstraction is not directly dependent upon them. The low level modules are not dependent directly upon high level modules. Okay. Both are depending upon abstraction, which interface is providing over here. So this is the way we can implement dependency inversion principle. Okay. So high level modules are directly dependent upon abstraction. Okay. And this light bulb and the switch class are loosely coupled. Okay. So they are not tightly coupled with each other. So with the help of which it follows dependency inversion characteristics. I hope you got the clarity and understanding for that. So this was it for today's video. I hope you got the understanding of basic solid design principles, and you can explain it to the interviewer very beautifully, and the interviewer will get impressed by your answer. So prepare it. Okay. Try to implement it in your IDE, and then you will get the confidence of answering the questions for the interview. Okay. So we'll see you in the next video with the next set of concepts. Till then, please let me know in the comment box, how was this video? How much have you liked? What all areas where you want me to work upon? Okay. I am also seeking for growth and improvement. I am also new into this teaching field. So if you can tell me that, it will be beneficial for me as well as for you. Okay. So we'll be seeing you in the next video. Till the next set of concept. Till then, it's Dave Jethwa signing off. Bye bye.